Hi, in this video, we're going to look more into detail into systems of linear inequalities. Okay, so last time we talked about how to graph a system of linear inequalities. In this video, we're going to do another example, and we're going to go more into detail about analyzing and looking at some of the situations going on here. Okay, so we have the two linear inequalities. Y is less than 2x, and 2x minus 5y is less than or equal to negative 10. Okay, so I'm going to graph the first inequality. So let's look at it first. It looks like it's less than, so that tells me that I'm going to have a dashed or a dotted line. And then it also tells me that I'm going to shade below whatever line that is. Okay, so let's go ahead and do that. Y is less than 2x. Well, 2x has a y-intercept. B is 0, 0. And it looks like the slope m is 2 over 1. So I'm going to use this information to graph the boundary line. Okay, so starting at the origin, and then up to right 1, up to right 1, up to right 1. I want to get a good line there. Same thing in the other direction. Okay, so I get a dashed or dotted line that looks like this. Okay, and let's make sure that I graph that correctly. Yeah. Alright, so this is what my line looks like. Okay, so now I'm going to do my shading. So I'm going to use, let's pick a highlighter. I think I'm going to use red. I'm going to use yellow this time. Okay, so I'm going to shade below. So under the line would be, the line is pointing in a positive direction, and it's going to be here, just to the right side, so under it. Okay, so now I'm going to shade the second inequality. Okay, but before I do that, I may have to do some things. Okay, so I have two ways in which I can figure out how to graph this. I can change it to slope-intercept form. So it's 2x minus 5y is less than or equal to negative 10. So what I could do is I can, and this is 2x, oops, 2x. So what I could do is subtract 2x from both sides to get it in slope-intercept form. And so that's negative 5y is less than or equal to negative 10 minus 2x. And so then I'm going to have to divide by negative 5. Now remember that when you divide by negative 5, that's going to reverse your inequality symbol. So instead of the result being less than or equal to, it's now going to be greater than or equal to. So these negative 5's will cancel. So y is greater than or equal to, looks like 2 plus 2/5 x. Okay, so my slope is 2/5. So greater than or equal to 2/5 x. I'm going to rearrange that quickly. And so y is greater than or equal to 2/5 x. Okay, another way that I could do this is to use the intercepts method. So I could find my x-intercepts and my y-intercept by plugging in a 0 while it's still in standard form. So instead of, so to find the x-intercept, it's going to be 2x minus 5 times 0 is less than or equal to negative 10, which will give me x is less than or equal to, because I'm going to divide by 2, that's going to go to 0. And so when I divide by 2, that'll be s is less than or equal to negative 5. So negative 5, x is less than or equal to negative 5 will be here. Oops. And then I'm also going to find my y-intercept. So that's going to be, this time I'm going to plug a 0 in for x. So that's going to be 2 times 0 minus 5y is less than or equal to negative 10. So I'm going to divide by negative 5, and so y is less than, and actually because I divided by negative 5, y is greater than or equal to 2. So that's going to be 0, 2 would be the y-intercept. Well, that makes sense because if I look at it, this would be my line, correct? It's going to look something like that, and it's going to be, it has a slope of 2/5. So if I were to start from the y-intercept, it would be at 0, 2, which is exactly where my y-intercept is. And I can use the point, and I can use a slope of 2 over 5 in order to find my next one. So if I were to go down 2 and left 1, 2, 3, 4, 5, that would create a positive slope. So I have it graphed from here to here, but I need more points. So let's go up 2 more and right 1, 2, 3, 4, 5. Up 2 more, right 1, 2, 3, 4, 5. And then I'm going to also go to the other side. So down 2, left 1, 2, 3, 4, 5. And that will still create that positive slope that I need. Okay, so let's connect all these points. And this is a solid line. Okay, so that one will be filled in, which means that the boundary points are included. Okay, and then this one tells me that I'm shading above. So I'm shading above this line. So I'm going to shade in blue. All right, so that's where my region is. So I can see I have a green region over here. So this region over here is where my solutions will be, and so I can test those. And so if it doesn't look right to you, just remember that when we divided by the negative sign, that changed everything. So actually y was greater than or equal to 2. And so also when we divided by -5, when we put it in slope-intercept form, that changed it to greater than or equal to. So that's where we're actually shading, okay? So it looks a bit different here because y is negative, or 5y is negative. But once we divide by -5, that changes it to greater than or equal to. So that's why we're shading in a different direction than what it looks like we should be here. Okay, so let's test a point to make sure that that region is correct. So I'm going to pick a point in my overlapping region, which is here. Let's try the point, let's say I'm going to use 10, 10 actually. That's a nice, easy number, the point 10, 10, and that'll be easy to check. So I'm going to check it in both inequalities. And so I'm going to check it 10. So in the first one, 10 is less than 2 times 10, an x value of 10. So 10 is less than or equal to 20. Well, that's true. Let's try it in the next one. 2 times 10 minus 5 times 10 is less than or equal to -10. Well, what I get is 20 minus 50 is less than or equal to -10. So that's -30 is less than or equal to -10. And that's true because as you go more negative, your numbers are actually getting smaller. Okay, so that point satisfies, so that proves that that is my region. And I could also test a boundary point if I needed to. I could test, let's say 5, 4. I could test the point 5, 4 if I wanted to do that. And so 4 is less than 2 times 5. 4 is less than 10. That's true. So this is my boundary check. And up here is just a region check. And always list the point that you're testing so people know what it is if you don't put it on the graph. Here I put it on my graph, so I'm still okay. So now let's test this and test it in the second equation. 2 times, looks like 5 minus 5 times 4 is less than or equal to -10. So that's going to be 10 minus 20 is less than or equal to -10. And that leaves me with -10 is less than or equal to -10. And that is true. Okay. So that works in my boundary. So basically, the green region here satisfies both the first inequality, y is less than 2x, and it also satisfies the second inequality, 2x minus 5y is less than or equal to -10. Therefore, the solutions to the system are the points between this boundary, including the boundary for the first inequality, but for the second inequality, but not the boundary for the first one. So notice that this line is dashed and this line is solid. So these points on this line are included, but the points on this boundary line, the dashed one, are not included. So it says give 2 solutions within the overlapping region. And so that would be the 10, 10 and also the 5, 4. And if you needed one, I'm not going to check this one, but if you needed to pick another one, let's say I would pick 6, 8. Okay, that could be a point, so I gave 3. Which inequality has solutions on the boundary? Well, obviously the second equation, the second inequality where it's less than or equal to, and it ends up being greater than or equal to. So I'm going to put the original 2x minus 5y is less than or equal to -10. Okay, that one actually has solutions on the boundary. And then it says, are there points where the boundaries intersect as solution to the system? Well, let's talk about that. On this boundary line, my solutions are included. On this boundary line, solutions are not included on the boundary. And so for a point to be a solution to a system, it has to satisfy both inequalities. Well, it doesn't satisfy the boundary where the solutions are not included, and so therefore the answer would be no, because one is a dashed line and one is a solid line, telling me that it does not that point of intersection will not satisfy both inequalities. Okay, so if both boundaries have solutions included, is the point of intersection a solution to the system? Well, yes, if both lines were solid lines, that means that solutions on both lines will satisfy each inequality, and so at the point of intersection, both inequalities will be satisfied. And so the answer would be yes, it would. Okay, And so it said explain here in part C, so let's go back and explain that, why it wouldn't be before. No, because the intersection point does not satisfy both inequalities. Okay, so I hope that this video and going through this problem example has helped you. There are two more inequality examples for you to graph in this lesson, so these are special cases, and I'll deal with some of these a little later. But I hope that this has helped, and you can go back through this video as much as you need to and review and just get lots of practice with graphing inequalities, because that's the only way you're going to get better at it. All right, see you in the next video.